This is an Action Potential Learning SAT mini lesson teaching you how to solve actual SAT questions to help prepare you for your upcoming test. I will be using the College Board official SAT study guide, and this problem can be found in the edition 2012, page 424, question number 15. This question is dealing with percents, where you have a length and a width of a rectangle, and you're increasing or decreasing that length and width by a certain percent. And the question's asking, what is the area of the new rectangle? So what effect does changing those lengths and widths have on the area of the new rectangle? Before we do anything, we need to make sure that we know exactly what's given in the problem and exactly what we're trying to find out. So what we know is that L, or the length, is increased by 30%, and that's the same thing as saying it's increased by 0.3 times the original length. So I've just converted 30% into the number form of 0.3. The width is decreased by 30%, and that's the same thing as saying it's decreased by 0.3 times the original length. So the length is increased by 0.3, the width is decreased by 0.3 times the original length. The question's asking, what is the new area of the rectangle? So after you know what's given and what you're trying to find out, you should also look at your answer choices to figure out what you're actually going to be doing in the problem. And in this problem here, you see that your answer choices talk about the area being increased or decreased by a certain percent or remaining unchanged. So for this effect, we're not actually calculating a number, but we're just telling what's actually happening to the rectangle. So there's two different ways to solve this problem. First, I'm going to go through the most straightforward way. And for those of you that are having trouble visualizing what's going on, I can go through a little bit longer way to help show exactly what's happening. When you increase something by a certain percent, that's the same thing as multiplying times 1 point and that number here. So for example, if it's increasing by 15%, you're multiplying by 1.15. So you're taking that percent and you're converting it to a decimal. If you're decreasing it by a certain percent, you're multiplying it times 1 minus that decimal point, that number. So increasing is you're just multiplying it times 1 point something. If you're decreasing it, you're multiplying it times 1 minus point something. Now in this example here, we're increasing the length by 30%. So the decimal point of 30% is 0.30. And again, if you don't remember that, if you have 30%, to convert 30% to a decimal point, you take your decimal and you move it 2 places over to the left. And that's how you would convert a percent to a decimal. So 30% is the same thing as 0.30. So if we're increasing by 30%, we're multiplying it times 1.30. And for the width, we're decreasing the width by 30%. So to decrease the width by 30%, we're multiplying it times 1 minus 0.30. And 1 minus 0.30 is equal to 0.70. So now we've got the numbers that we're dealing with, but what does this actually mean? What do we do now? Well, since the question is talking about the area, we're trying to figure out what the effect on that new area is. We need to understand what area actually is. So area is length times width. Now we know that the length of the area has increased by 30% and the width has decreased by 30%. And we've converted that into a number form. So our increase factor is 1.30 and our decrease factor is 0.70. Since our answer choices only want us to talk about the trend, right? So what the effect on the percent increase and decrease has done to the rectangle, all we need to do is multiply these two numbers together. And I'm multiplying it again because what we're concerned about is the effect on the area. Since area is length times width, we're going to multiply the effect of the length, which is 1.30, times the effect of the width, which is 0.70. When we do that, we get 0.91. So what does 0.91 actually mean? It means that if we started off with a certain rectangle, the effect of that rectangle after some change has occurred becomes 0.91. So if we started off at 100%, and 100% in the number form is 1, and we wind up with 0.91, that's a change of 0.09, right? So 1 minus 0.91 is 0.09. 0.09 convert it into a percentage. We'll move that decimal place over 1, 2 places to the right, is 9%. So what this means is that we started off with a perfect rectangle, whatever the number is. We'll just call it 100%. That's just what we're starting off with. And based on what's happened here in the length and the width, it's increased and decreased by a certain percent, we wind up with 0.91. So that's a change of 9%. And because 0.91 is less than 100%, it's going to be a decrease. So E is the correct answer. So for those of you who are having trouble visualizing it, we can go ahead and draw a rectangle and work it out that way. So let's start off with a rectangle. And what we're going to do now is label our rectangle with the length and the width. I'm going to create some numbers here just to demonstrate for you. So for example, let's just call the length 100 and the width 10. It doesn't matter what numbers you choose. It's usually easier to use something with a factor of, 10, 100, something like that, just because it's easier to calculate percents, but you can choose any numbers that you want. So after a change has occurred, what we notice is we have a slightly longer length and a slightly shorter width, right? Because the length has increased by a certain percent and the width has decreased by a certain percent. Since the length has increased by 30%, your new length is 130. And since the width has decreased by 30%, your new width here would be 7. And the way that we get this, if you have 100 for your length, so the length is 100, and you multiply that times 0.3, that's 30%, you end up getting 30. Since the length of the rectangle has increased by 30%, we'll say 100 plus 30 is our new length, which is 130. For the width, you start off with 10. We're going to multiply that by 0.3 because we're dealing with 30%, and we get 3. Since you're decreasing the width by 30%, we're going to say 10 minus 3 is 7. So you calculate a certain percent, you multiply the percent times the number that you're starting with. You add it if you're increasing, you subtract it if you're decreasing. And that's where I got these numbers from here. Now, since we want to know the effect on the area of the rectangle, I've got my two rectangles here. I've got the original rectangle and the final rectangle after some changes occurred. We can calculate the area for each one. So here, 100 times 10, which is the area of the length times the width, is 1,000. And the area of this rectangle is length times width, and 130 times 7 is 910. So when we're looking at the area, we can see that the area has definitely decreased from our original figure, right? So the original figure was 1,000. When we put these changes into place, now the area is 910, so that area has decreased. And since it's decreased, we can look at our answer choices and automatically eliminate the first three, A, B, and C. And we can eliminate them because we know that it's not unchanged, right? This number is different from this number. And we know that the final figure hasn't increased because this number is smaller than this number. So now we're left with two answer choices. Finally, you'll need to calculate the percent change to figure out how much it's actually decreased by. So the percent change is a formula that you can memorize. You will probably see this again on the SAT. Now you don't need to use this method, right? You could use the first method that I taught you, but this is another good way of solving. So you take your new value, which is 910, you subtract the old value was what we started with, that's 1,000, and you divide that answer by the old value. So we have 910 minus 1,000 over 1,000, and that gives us negative 90 over 1,000. Negative 90 over 1,000 is negative 0.09, and if you'd like to convert that into a percent, it's negative 9%. We've got our negative value here, which tells us that this has decreased, so E is our correct answer. So there's a few takeaways from this problem. The first that is you need to understand how to calculate percent increase and decrease, and you can do that in a variety of ways. You could do it the long way, like I've done here, and actually use a percent change formula. Or you could use a shortcut and just remember that when you increase by a percent, you multiply a number times 1 point that percent. And if you decrease by a percent, you multiply it by 1 minus that percent. Either way, you get the exact same answer, but the key here is to understand how increasing and decreasing percents will affect your answer. You will definitely see some kind of problem like this on the SAT, so it's important that you're familiar with how to calculate these problems. This is an Action Potential Learning SAT mini lesson. Thanks so much for watching.